Hello everybody, I'm here with an example of Mohr Circle. So we want to use Mohr Circle to figure out the principal stresses, sigma 1, sigma 2, and the maximum in plane shear stress for this stress element that we have here. Remember now, this stress element basically is the state of stress at a point on a structure, and it's usually a critical point on the structure. And once you get those stresses, your normal stresses and shear stresses, then you're trying to find out what are the maximum normal stresses, sigma 1, sigma 2, and what is the maximum shear stresses, shear stress. And those are actually used for later on for the failure theories and failure criteria, which you will see in another course. Okay, so how do we plot a Mohr circle? So the first thing you want to do is basically figure out what your stresses are, sigma x, sigma y, and tau xy. So normal stress in tension is positive, 50 megapascal, right? That's sigma x. As you could see, sigma y is in compression, so that would be minus 10 megapascal. And this tau xy acting up like that, by the way, would be a positive shear stress. So remember, in the previous video, you saw that point A is our reference point, and then it would have the coordinates of 50 and 40 because the coordinates of point A basically sigma x and tau xy. And then center has the coordinate of sigma average and 0. So go ahead, find sigma average, which is sigma x plus sigma y over 2, right? So that's 50 minus a 10 over 2, that's a 20. So center has coordinates of 20 and 0. Now, before I draw the Mohr circle for you guys, just remember that we already have formulas for calculating the principal stresses. You remember in an example I did. And I can already tell you that we ended up getting sigma 1 to be, if I'm not wrong, to be, let's see, 70, and sigma 2 was minus 30, I believe, and tau max came out to be 50. So we already have done this problem before and we have the answers. But I want to do this for you graphically, which hopefully will make better sense if you look at the graphical way of doing these type of problems. So I'm going to take a short pause and draw the circle and then come back. Okay, so this is how we draw the Mohr circle. So what we need to do is to draw our horizontal axis, sigma. So positive sigma is to the right. And remember, positive tau is downward. And then first locate the center of the circle, which has a coordinates of 20 and 0. So basically, if you say each segment here is 10, so that would be 20 and 0. And remember, center is always on the sigma or horizontal axis. And then just locate where this point is, which is basically this plane here. So A with the coordinates of 50 and 40, so basically 30, 40, 50, and going down 40. 1, 2, 3, 1, 2, 3, 4, somewhere here. Okay, this is not to scale. So that's 50 and 40. So then connect C to A, and that establishes the radius. And then draw your circle, as you could see. Okay, draw the circle. And now your maximum normal stress, which are the principal stresses, happen to be on the horizontal axis. So this is sigma 1 and this is sigma 2, as you've seen in the previous video. So look at this equation here, guys. This is the coordinate of the center, or sigma average, and this is basically the radius. So sigma 1 basically is sigma average, which is the coordinate of the center, plus r. So sigma average is 20. And if you calculate the radius, by the way, this is 30 and this is 40. So the radius becomes, actually, you could even use this formula if you want. But it turns out that, I'm sorry, you could use this formula for the r, which is square root of sigma x minus sigma y over 2 squared plus tau xy squared, which is basically happens to be 30 squared plus 40 squared. Take the square root. So r becomes 50, So as I was just saying, that sigma 1 then would be 20 plus 50, so that's 70. So this guy now is 70. That's your maximum, one of the maximum or the principal stresses, and sigma 2 basically becomes sigma average minus R. So that would be 20 minus 50, so that happens to be on the negative side, or negative 30, and that's your negative 30 right here. And just keep in mind that your tau max actually is the radius, which happens to be 50. So you see, those are the things that we got earlier when we did the problem based on these formulas, right? Okay, so now remember 2 theta 1, in order to go from point A, which is right here, to the principal plane, which is where we get 70, your 2 theta 1 actually, if you do the calculations here, even in this picture, you could see is inverse tan of 40 over 30 here. But it comes out to be about 56 degrees. But of course, on the element, that's about 26.5 divided by 2. Remember, everything, all the angles on the element are theta, on the Mohr circles are 2 theta. So in order to go from this point to the principal plane, right, to here, right, we have to go counterclockwise to a plane counterclockwise, equivalent to 26.5 degrees. Okay, so basically, as you've seen in the past, let me just erase this Mohr circle here so I can draw the rest of the diagram for you here, right? So this is theta 1, 26.5 degrees. So over here you would have the 70 sigma 1, right? And over there 90 degrees from that, right? 90 degrees or 180 degrees on the Mohr circle, you get sigma 2, which is the 30 in compression. And that's it. Look, there's no shear stress here or shear stress here because we are on the sigma plane. That's why on the plane of maximum or principal stresses, shear stress must be equal to 0. Now remember, 45 degrees to that, you would have the plane of maximum shear stress. So if you go 45 degrees from point A, right, you get what? You get the plane of maximum shear stress, which is basically going counterclockwise, right? You see, counterclockwise from your theta 1 of 26.5, right? I'm sorry, from here, from point A, go 90 degrees. Again, sorry guys, from sigma 1, 90 degrees. Sorry guys, I'm getting these messages from my phone and it's distracting me. So you get to here, that has the coordinates of 20, which is the center, and R, which is your tau max, which is 50. So here we go. A 50 and a 20. 20, 50. And same story here. 50, 20. 20 and 50. Remember, the shear stresses, they have to be all equal on all 4 faces. Just check, guys. Notice that sigma x plus sigma y is the same as sigma 1 plus sigma 2. So any 2 perpendicular plane, the sum of normal stresses must be the same. So you see, we've done this before, nothing new. 50 minus a 10 is the same as 70 plus a minus 30. Notice also this sum of 40 that I got for you here, 40 equal 40, obviously also works here. 20 and 20 is what? 40. Okay, so any 2 perpendicular planes, the normal stresses, the sum is an invariant. Just again, another point here, guys. Point B right here is, and the circle is right here with the coordinates of, so this is point B. What are the coordinates of what is the coordinate of this point? The coordinate of this point, as you could see, would be sigma y, which is minus 10, and negative tau xy 40. And that's pretty much what it should be. That's about minus 10 and this is about 40 here. Okay, remember in the video before that I called this point D. Point D is right here, where you have the coordinates, and point E, if you want to call this point E, would be right here, right? Because between D and E is what, 90 degrees here, but in the Mohr circle, that's what? That's 180 degrees. Okay, I hope I haven't confused you. I want to do one more example for you on just having the same stress element that you see here, and then try to look at it, just some arbitrary planes. Okay, as always, thank you for watching and listening. Stay safe and well. Thanks.